Okay, number sequences. It's a list of numbers where there is a pattern called a number sequence. The numbers in the sequences are called the members or terms of the sequence. So, for each of the following sequences, describe the pattern and find the next two terms. All right, look at that. Look at A. Can anyone tell me what's happening? Going down by 3, so what would the next two terms be? 9 and 6, so going down by 3. Beautiful. What about B? What about B? Divided by 2 each time or halving each time. So what are my next ones? 1.5. Yes, decimals can happen. And also negative numbers could happen. Okay, so halving each time. All right. Ooh. 2, 8, 32. Does anyone know? Yeah. Close? No, not quite. Okay, I think you know. You have noticed something. Yes. Anything else? Yes. Well, it actually is timesing by 4. I think what Lily was thinking and what I was also thinking. This is like 2 to the 1. Then the next one is 2 to the 3. The next one is, does anyone know? 2 to the 5. So the powers are going up by 2. However, it doesn't need to be that complicated. Just multiplying by 4 each time is fine too. So let's write that down. Multiplying by 4. Oopsie, whoa. Can anyone tell me what the next term is? Beautiful. Does anyone want to try the next term? 512? 512? Beautiful. Sequences of numbers again. Now, we're going to use rules in terms of n, much like a patterning task. Okay, a number sequence is a set of numbers defined by a rule in terms of n. So n is 1, 2, 3, 4. It's never a negative or a 0 because it's like the number of term or it's the position. It's either the first term or the second term or the third term. There's never a 0th term or a negative first term. It's always positive. So basically, n is bigger or equal to 1, and it's an integer. Okay, so list the first 5 terms in the following sequence. In other words, you're just substituting n is 1, n is 2, n is 3, is 4, 5. If you wanted, you could even do a table where n is 1, 2, 3, 4, 5. And the term, let's just put term here. Well, so girls, when n is 1, what do you get for that first? So basically, in here, we use these curly brackets, but in here is the rule. So put n is 1, substitute n is 1 in there, and what do you get? Just 1. 2 times 1 is 2, minus 1 is 1. When n is 2, what do you get? 3. When n is 3, 5. And you notice a pattern, don't you? They're going up by 2. So it's 7 and 9. Beautiful. This next one won't have that kind of pattern, but have a go. So what's the first term? No. 6. When n is 1, you get 2 to the 1 is 2. 2 times 3 is 6. What's the next term? And I might just write up, this is when n is 1. What's the next term? 12. Now, I'm writing it as a list now just to show you that you can. You could either write it as a table or a list, whatever you like. N is 3. 24. Try and do what you can without a calculator because you may have to. That's n is 3. N is 4. 2 to the 4, 4 to the 8, 2 8, 16. Yep, 16 times 3. Yep, I'm with you. When n is 5. 96, yes. Beautiful. Everyone okay? All right, have a go at the next one. Can anyone tell me the first term? 3? Let's talk about it. When n is 1, what's negative 1 to the power of 1? Negative 1. What's negative 1 to the power of 1? Negative 1. 4 plus negative 1? 3. Anything to the power of 1 is just itself. And 4 plus negative 1, that's the same as 4 minus 1. Girls, what happens when n is 2? You get positive 1. For negative 1 to the 2, because it's an even power, you get a positive 1. So 4 plus 1 is? 5. What's the third term? 3 again. It goes back to 3 because negative 1 cubed is negative 1 again. And 4 plus negative 1 is 3. And so what's going to happen next? 5 and last term, 3. It just alternates because that's what happens with the negative 1 power.